Hello, welcome to this teaching for this day. This is Darlington Gospel again, and I'm here to bring you a fresh batch of tutorial for your Solidity learning. So in our series that we've been shooting and learning is called Capturing Smart Contract Development, as you may have noticed. So in today's teaching, I want to teach you about making batch payments with Solidity in your smart contract. There will be a scenario where you have to be able to make batch transactions, like be able to pay out a set of workers. So for today's tutorial, I'm going to be teaching you about payroll system, creating a payroll smart contract in Solidity for making batch batch payments at once. So if you're ready for that, I want you to hit that like and subscribe button, hit that notification bell, and then we'll get dapping right now. Hello, welcome to this stream again today. This is me, Darlington, and here we have Covenant, my favorite student. Today we want to code another smart contract. We want you to capture a great understanding about Solidity development. That's what this series is all about. So in today's class, I want to teach you guys how to code a batch payment, a smart contract. For example, we're going to be doing a payroll system where workers can be added, and then those workers can be paid at once by a company or whatsoever. So if you're ready, let's get started. Please make sure that where you're coding this smart contract along with me is in your remix.ethereum.org, the ID, the online ID. You can't use mine because I'm using mine for collaboration reasons. Okay, so when you want to test out this code, when you want to code your own, please go to the remix ID online to perform those operations. So with that said, I'm going to quickly jump into this tutorial and get it started right now. So as always, we're going to create a file here. I'm going to create a file here. Let's call it payroll.so. So its name is all payroll.so. I'm going to jump in and actually copy some codes from our previous developments to facilitate the process. So this is called payroll. Okay, so are you here with me, Covenant? Are you on this file? Okay, to get started, so this payroll system, basically we have a list of employees that we can add to this payroll, and then we want to be able to pay all of these employees with just one click of a button. Do you understand this flow now? Just like a government payroll. So we want to create like a payroll system where people can be paid at batch. All right, you understand? So that is a very necessary smart contract development skill that you need to grow up as you're diving deep into your journey as a blockchain developer. So with that said, let's get started. Let's create these various variables first that are very essential for the state of our smart contract. The first thing we want to do is create an address. This is what's going to be public, of course, and this is going to be called the company's account, company account. So basically, this payroll belongs to a company, of course. So this is the company's account. This is where the company's address is. So we're just taking note of that. Anywhere you have question, please make sure you ask me. All right, don't hesitate. All right. So afterward, we need to create a company's balance. So this is why this will hold the account. This is on signing TJL. Please take note. Why this will hold the account, the bank account or the address or the Ethereum wallet of the company. This is going to keep track of what their current amount of money, that they have in their balance. So that is what it is. Okay, so this particular variable holds the current amount of money the company has in this smart contract. Do you understand that? Okay, so now this next one, we're going to call it total workers. Okay, this is going to keep track of the total number of workers a company has, and this one is going to hold total salary. Total salary. Basically, it's going to hold information about the total number of times salaries has been paid using this smart contract. Do you understand that? And then the last one is actually total payments. So this will be like the total number of amount of money that has been, disbursed from this smart contract. Why the total salary? The total salary, we capture information pertaining to the number of times payment has been made on this smart contract, or salaries have been paid on this smart contract. This total payment is going to capture information regarding the total number, the total amount of money that has been paid. You understand? There is a difference between them. This one total number of times, this one total number of money paid. So please take note of that. Understood? All right. So with that said, let us actually create a mapping here. Okay. This mapping is going to want to be able to track if this person is a worker. You understand? For example, want to be able to pay salary. Only want to pay to people that are on our list that are workers, so that you can't just insert a random a stranger's account and that stranger actually becomes a beneficiary of that salary. We don't want that kind of situation. So we're using this mapping here called is worker to determine those that are workers, or differentiate those that are workers and those that are not workers. Is that clear? All right, so this is an event. Okay, event is Solidity just emits some extra set of information to the word EVM. So what I want to do is, whenever a payment is paid, okay, paid, one salary is paid, I want this to be emitted. All right, and for this to be emitted, this is, make sure you end every line with semicolon. This is what we want to emit. We want to be able to emit an ID. Okay, we want to be able to emit, where is this? This is an address, of course. Where is this coming from? Okay, so basically, let's say paid to. Okay, let's change it to. All right, this is going to be where the money is going to. You understand that? And then want to index this because we want to be able to use this as a filter, a filtering tool. All right, and then want to be able to say the total, salary that was paid out in this particular batch of payments. You understand? And lastly, want to be able to keep the timestamp. Okay, so these are very essential for administrative details. Okay, administrative reasons. All right, so next thing we want to create a struct. This is a structure of what? Each payment will carry this structure. That is what I'm simply saying. So I call it payment struct. All right, and these are the information to carry. To carry the ID of this particular payment, it will carry the address of the worker that is to be paid. Okay, and it will carry the salary, which is unsigned integers. It will carry the salary that this worker is being paid, and then it will carry the timestamp. Okay, why salary and timestamp are what? Unsigned integer, because they are numbers. Address is what? For worker, it captures Ethereum wallet address. Okay, so these are the information that each payment structure is going to carry. All right, and with this structure that I just established now, I could come to the top here and create a variable, a state variable that carries this payment structure data type. So I'll say this payment structure data type, and I'll call this variable called to be what? Employees. You understand this thing? So this variable is going to capture employees, and each employee has a payment structure. Okay, but since I'm going to be capturing more than one employee, it has to be an array. So this is how you represent it in Solidity. So this payment structure points to this. By me putting this array symbol in front of it, means that it's going to have a collection of this payment structure. This payment is going to contain multiple payment structure, and each payment structure points to a worker, his ID, and what payment his salary. You understand that? Fantastic. So I want to introduce you to a new concept here, because I've not actually shown you before, but this is called function modifier. Okay, basically it is very important. Do you know when we normally do if msg dot sender, like we used to do something like msg dot sender, you understand, is equal to what? Owner, right? Yeah, so we want to use a function modifier to change the approach through which we actually do all these kind of requirements in our function. So we're going to use something called function modifier, and it will be a lot more cooler than how we normally did it before. So this is how you do it. You say modifier, the keyword modifier, and then you call it owner. Let's call it owner only. Okay, it's more like a function basically, but it's not like a function. Okay, so I'm spelling something wrongly here. It's called modifier, hence the color is showing properly now. So, and then it's not going to carry any parameter, but I'm just going to say this parenthesis here, and this is where I run a logic. I say require. It requires that the msg.sender is equivalent to what? The company's what? Account. So, not the company's balance, company account. Okay, so this is a function that is, if we call this function in any other function that we're using, if we're calling this modifier in any other function that we're using, it's going to perform this logic that I'm specifying here. The logic here is that any function that bears this modifier, it will limit that function's execution based on the criteria that the caller of this function is the what? The company's account. Do you understand that now? Alright, so but if this person is not what? The company's account, let's say, let's say company, okay, reserved for company only. You understand that? So that would be like the message that is going to throw up on the console, for whomever try to operate a function that carries this particular modifier. But lastly, one more thing here is that you don't end here, you end with this particular keyword here, underscore semicolon. So after you've made your specification here of the rules that you want this modifier to follow, you always end with what? Underscore semicolon. It's just a Solidity convention. All right. So now we want to declare who will become the company's account using the constructor, as we always have done before. So we say constructor here, this company's account is equal to msg.sender. msg.sender will become the company's account. Do you understand this now? So whenever we deploy this smart contract to the blockchain network that we choose, the company's account will become whomever deployed that smart contract. Are you with me? All right, with all this smaller stuff done, let's head in to create our first function. This function is going to be called add worker. You understand? Add worker, okay, or let's call it add employee, okay, employee. All right. In adding an employee, we need the address of the employee, right? Okay, and then we also need the salary scale. How much do you intend on paying this employee? All right. So these are the two information that we need. Okay, whenever we are adding an employee. All right, and then we say that this is public and returns. No, let's just leave it like that. And then okay, this is the body of the function, but there's one extra thing that you need to take note of here. We don't want anybody to just come and add an employee to our database. Do we want that, right? We don't want that, right? So before we will do something like this, require that this whomever is trying to call this function is the company's account. Is that not correct? But this time around, we're not going to use that method. We're going to say that owner only. You understand? Owner only. We're just going to specify that by us just doing this, it will cater for all these validations here. Do you get that now? Yeah. So this is what is called function modifier. So this thing is modifying the behavior of this function. That is what it simply means. Okay. All right. So let's put some extra requirements here. We want to require that this particular, before you add an employee into your database, into this smart contract, we want to be able to make sure that the salary is greater than 0 ethers. So we don't want you to try to put an employee or a worker with 0 ethers. The salary must always be greater than 0. That is what we want to ensure. Otherwise, we should say salary cannot be 0. Okay, and another criteria I want to set up is want to make sure that is worker, okay, this person is not a worker. Okay, this person is not already found in a worker array. So that means right here, okay, in this place here, he's not already a worker. All right, if he's already a worker, we want this thing to say record already exists, or record, or say employee record already in existence. Do you understand that? So if the criteria is that this must not be an existing worker. If this worker is existing, we should say employee record already in existence. Do you understand that logic? And to even make this thing a lot better, I want to call it worker exist. You understand that? So this thing is simply saying now worker not exist. Okay, we want to make sure that the worker does not exist before we proceed to adding more flesh to this function here. All right, so with that done, now the next thing I want to do now is to say that the total number of salary, okay, total salaries that we as a company are going to be paying, okay, must be increased by the salary of that particular worker. So that means at the end of the day, okay, this total salary is going to hold information about the total number of salaries that this company is going to be paying per month. Do you understand? Paying its employee per month. So want to what? Top it up here. Okay. And next, want to declare that this worker now exists. Okay, worker exists. Okay, and then I'm saying MSG, not MSG.sender, actually this worker is equal to what? True. So now by declaring this line, I'm saying that this worker now exists. You understand? So after that is done, I just want to what? Push this worker into what? The worker's, let's say, employee. Sorry, employee. Okay, I want to push this new worker, okay, into this what? Employee. So I want to say employees.push, and what am I pushing? I'm pushing the new worker. The new worker is going to take that payment struct, or let's just change this payment struct to something like worker struct. You understand? Or let's say employee struct. Employee struct. Okay, so I've changed that in every place that it's applicable. Okay, so by me writing that little line, I just did it. All right, so this employee struct is going to contain what and what? It's going to contain total worker. Okay, but I'm going to increment it by 1. So basically, the first time that this, I'm not going to do it this way. Let me do it this way instead. I'm going to come here. I'm going to make sure that I put this total worker here. I'm incrementing it by 1. So the worker ID for the first person is going to be 1. I want it to start with 1. I don't want it to start with 0. Okay, so basically now this is going to be what? 0 by default. No, 1 by default. The total worker for the first time that I'm creating or I'm adding an employee is going to become what? 1. Do you understand that? So now, when I'm adding this, the ID of this employee is going to be, this is basically 1 now. And then I'm just going to add the worker. The worker is basically what? His address. Okay? And then the salary is how much salary that I want to pay him. And then the timestamp will be what? Block the what? Timestamp. You understand that? This will push this employee into this what? Employees array. You understand that? This will push it into this employees array by doing this employee.push here. Okay, that is going to add it in there. Alright, so that is it for this function. You understand? So that function is, we're done with that function. Let's create another function called we'll call this function pay workers or pay employees. Okay, so function pay employees. Pay employees. Okay, what is it going to do? Because it's going to be public, right? And I'm just for making things a lot cleaner, I'm going to say returns bool here. So at the end of this day, I want to say return what? Return true. Okay, so for this particular function, one will maintain that clean flow. All right, so now you know that for this function to also run, it has to be what? The owners of this smart contract, they are the only one that are permitted to execute all this sort of administrative tasks. So I'm going to say owner only as well, and it's going to returns boolean at the end of its execution. Okay, and then yes, you can create many modifier and add it to what? To a function. All right, like this is one modifier. You can create another modifier and attach as many modifiers as you want here to a particular function. Yeah. So with this done, we want to make sure that so basically, whenever you want to pay workers, okay, you'll be paying it from a specific account. All right, what I mean by that is, I want to say this function is payable, okay, because this function is going to receive money from the company and then pay it to all the workers that they have. Do you understand that? That is why I'm adding this payable here. Remember, for a function to receive money in Solidity, this clause called payable must be attached to it. This attribute called payable must be attached to it. So that's fantastic. You get that? All right. So the next thing I want to do now is to put some guard around this. I want to say require that msg.value. So basically, msg.value is the amount of money that you want to pay these employees now. Like the cumulative amount of money that you're going to pay all your employees at once. For example, if you have 10 employees and each one of them are taking 10,000, so that means the amount of money that you need to pay these 10 employees, what, 100,000, right? Okay, so what I'm saying now is that for this msg.value, which is the money that you're passing into this function, we want it to be that it's greater or equal to, okay, the total salary of what, all your employees. Otherwise, you say insufficient balance, insufficient amount, or insufficient fund. Okay, so insufficient fund will be what will be given to as a response in a situation where this validation does not pass. The next thing we want to do is we want to make sure we pass another validation here. What we are saying here is that the total salary, okay, let's put it this way without confusing you. The company's balance, okay, is greater than or equal to what? The total salary. You understand? So because you're trying to pay a group of people, right, from the company's account, so I want to know that the company's balance will be able to sponsor this payment. Okay, are you with me? Okay, so if there is any modification, we're going to make it before we finish up this build. So instead, say insufficient balance. Are you with me? So there is a little modification I want to do here. The modification, I want to remove this first clause. I don't want this to be payable, because I want to dedicate a special function, a unique function that will fund this balance, the company's balance. So I don't also need this one here. Okay, so this is what I need here. This is the only criteria that I need here. Okay, so now that that is done, let us pay all the employee that we have in our record. So we use a for loop to do this thing. We use a recursive or a loop statement. So to write it, we say for uint I. This is the counter, basically. It's going to start with 0, of course, and I until I is less than employees dot what length. Employees dot length. Okay, I plus plus. So basically what I'm saying is I'm creating a variable because you need this in Solidity. You need to create this way. This is just basically how you write it in JavaScript even. So I start with the counter or the index starts with what? 0. Okay, and this index continues until it reaches the total length of employees that we have. Okay, otherwise it should continue increasing this counter by one until it finishes the array of employees that we have. That is what we are simply stating here. And now we want to pay these employees now. To pay them, I'm going to borrow a logic from this particular function that we created before, this pay-to function. All right, so I'm going to paste it here. Okay, remember this function? So this function will be responsible for what? Making the payments to what? Each one of the employees. So I'm gonna call it in this place. I'm gonna say pay to. All right, I'm gonna pass in the employee. I'm gonna target the index of that employee. Okay, and I'm gonna say dot worker. Okay, this worker basically is his account. Okay, this is what his account. All right, so I'm gonna what now also target employees, this same person, his salary. Do you get that? So I'm gonna pay this worker his salary. That is basically what I'm saying. You understand that? So, but I'm doing that, I'm looping through an array and doing these things all at once, you know, even though I have like 1 million workers. This little piece of code here, this little highlighted part is going to pay every one of them. Okay. Okay. So now with that, I want to what? I will say the total payment that has been made on this platform, I want to what? Increase it by what? 1. That is what I just did. And I want to what? Reduce the company's balance by what? That amount of money that I paid at all these workers. Okay, which is what? The total salary. Which is the total salary. So I'm removing that total salary from the balance that we have in the company's balance. Okay, so and lastly I want to emit this this particular event that we created above. So this event here, I want to emit it. Okay, on emitting this event, I'm going to say the ID will be what? Let's say total payments. You understand? That would be total payments. That would be the ID of this total payment rate, and the address, you know. Okay, we want to call this thing from. I see why I named it from before. I want to change this to from. If you come here, I want to also change it, you know, from. Are you with me? I want to change it. Why I'm changing it? Because I want this from to be the address of the person that made this payment. So the company's accounts should be what? Where this money is coming from. Okay? Yeah, so I'll say company's what? Account. And then the total salary, basically, that is the total amount of money that we paid out in this particular batch of payments. Okay, and then the block the timestamp, of course, to take record of what? The time that this particular payment was made. Lastly, I want to say return what? Bool. No, return true. Okay, so I'm done with this function. Are you with me? Do you have any question? All right, fantastic. So now let's create another function. This function is going to be called fund company's account. Okay, because this is a balance. This is where the money is going to be removed from to pay all of these workers. Okay, so if there is no money in this if there is no money in this company's balance, this operation of paying your employees cannot hold waters. Do you understand it now? So let's create a function called fund account. You understand that? And this fund account is going to be public, it's going to be payable, and anybody can fund us basically. All right, so it doesn't have to be the company is funding us. Anybody that wants to fund us can fund us, you know. All right, so I'm looking for who to fund me too. So if you want to fund me, you can fund me. Okay. All right, so we want to just make sure that put a requirement here that whomever is trying to fund us is not the company's account itself. All right, because the company account shouldn't be funding itself. You understand? So you want to put that particular guard there. So otherwise you should say what? You can't fund yourself. Okay, you get that? Okay, so with this you'll be able to receive money. And of course I also want to put one extra guard here. I'm going to just copy this one here. I'm going to say that msg.value, so this amount of money that you're trying to send, must be greater than what? 0. Otherwise you say insufficient amount. You understand that? So you can't send us 0 ethers. Otherwise you say what? Insufficient amount. All right, and after doing that, the next thing you want to do is what? Say increment the company's balance by that msg.value, that how much that was funded to us, and just say return true at completion. So this piece of logic here, we fund the company's account. And lastly, for this particular smart contract, let us get all the workers. We want to be able to get the workers. All right, so let's say function get employees. All right, to get employee, we say public, of course, and it's going to return a view returns. All right, the data type that is going to be returned is employee structure, and it's going to be memory. It's going to be stored in the memory, but you know that it's not going to return just one employee. It's going to return an array of employees. So that is why we put it like that, and we just say return, you understand, employees. That alone we return all these employees, to us. Hope you understood that, because we're just through with it. This is how you create, a payroll smart contract, with Solidity, and it will make batch payments processing. So I'm going to jump in, to testing out this code on the Remix ID. So you're going to follow me and watch how, when I make payment or I pay my employee, you see that all the employees receive the specified amount of money for them, each one of them. So if you're ready for that, let's jump into that Remix ID right now. Okay, and here we are in the Remix ID online. Okay, if you want to be here, just visit remix.ethereum.org. The reason why we're here right now is so that I could test out this payroll smart contract for you, and so that you can see how the entire process goes, because without testing you can't be sure that everything works, right? So let's get started. All right, as always, create a new smart contract in this contract folder or directory. Let's call this payroll.so. So you open it and you paste the entire code that we actually ran our Solidity smart contract on. This is a smart contract that we just finished coding, so we want to test it out. So you click on save, which is this control save or command S, or you can just come to this place and click on this compile. So compile successfully is if everything is correct, and it will show this green check mark here. So our own was actually correct. Fantastic. So now let's go about and actually test it out. We deploy it into the network. We choose this Berlin, and then we just deploy. Okay, the smart contract is deployed now, and you can see all the various functions that are available in this smart contract, this payroll system now. So for example, if I click on this total worker, I see that it's 0, total salary 0, total payment 0, get employee, there is no employees, company's balance is 0, company's account is this, and all of these things are available. These are the 3 functions that we want to be working on. So as always, let's start out with adding employees. So I'm going to add about 3 employees here. So I'm going to copy this last person and come here, click on here, this the worker, his address, and I want to, let's just say times. I want something like, I want to be able to pay this person about 1 Ether. So let's say 100, okay, 00, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this person, I'm going to pay this person, the salary for this person is 1 Ether. So we're going to pass that, and the transaction went successfully. I'm going to add another worker. So I'm going to choose the second person here. I'll add that account. This, and I'll pay this person 1.5 Ethers and add this person here. See, went successfully. I'm going to add a third person. Let's copy this and let's just come here. Let's just, instead of choosing this deployer account, the company's account, let's try to actually add a worker from a different account. So I'm adding this, and this person is going to be 2, that is 2.5 Ethers. Okay, and click transact. It fails. It says what? Reserved for company only, because this is not the right account. So I'm going to change this to the right account now, and I'm going to come here and click transact. You see it was successful. Now let's check the let's check get employee. Click on that. You see we have about 3 employee right now, because we click total workers at 3, total salary is 5 Ethers. So 5 Ethers is what we supposed to pay all these employees at once, and total payment is 0, because we've not made any payment yet. So what we're going to do now is try to fund account, because if we click on this pay employee, says what? Insufficient balance, and that is correct, because right here we actually specify that the amount that is available in the company's balance must be able to sponsor the payment of what? The total salaries for all the employees. So now to resolve that, I'm going to come here. Let's say this middle guy, and fund, change that to Ether. So I'm going to fund it with 6 Ethers. All right, so I'm going to click on this fund account, and that went successful. And you can see here that I have 6 ETH available to me, and you know, when I check the company's balance, it's actually 6 ethers that are available to me right now. So this will be available for paying out the workers. Okay, so I'm going to go back to this particular administrative account, or the company's account, and then I will click watch. This is the ultimate test. Look at this last 3 accounts right now. They are at 0, 100 ethers. So watch what happens when I pay this employee. Click on pay, successful. Now I come here, and you see each one of them received the amount of salary that are actually, you know, specified for them when I was entering their details. So the first person received 1 ether, the second person received 1.5 ethers as salary, and then the third person received 2.5 ethers as their salary. You know, in total that is what, 5 ethers, because now when I check here, my balance is actually 1 ethers remaining, 1 ether. And if I check the company's balance, I see that is actually what, 1 ether remaining, and total payment is 1, because I've only made 1 payment, and one run of payment, 1 cycle of payment, and then total salary remains the same, and then total workers remain the same. Basically, you see that you were able to pay all your employees in one go, in one click of a button, which is this. Now, if you can actually, you know, take this smart contract and make a DApp out of it, right? Let's say you can use your React front end, or your Vue or your Angular front end, and hook it up together and have this thing interacting on a web view. So this is it for this tutorial. I hope you got values on how to create a payroll, which basically is a batch payment system with Solidity. And if you enjoyed this tutorial and you want to see more of this coming, I would like you to, you know, subscribe, hit that like, and hit the notification bell button, and I'm going to see you in the next tutorial.